This is a 2 days workshop. Just we are going to do the basics of Verilog. Does anybody know what's a Verilog is? Okay, for day one and day two, I'm going to go through these contents. First, I will be giving you an introduction about what Verilog is and just an idea about VLSI design flow. What are the different stages in a VLSI design? Then I will discuss a level of abstraction in Verilog, which contain different modeling. As I mentioned, the switch level, gate level, data flow, behavioral. In each modeling, we are going to discuss various examples, and we will doing the simulation and coding part in EDA playground parallelly. Okay, so Verilog, as you all know, Verilog is a hardware description language. Does anybody know what is Moore's law? Moore's law, Moores law. So Moore's law states that for every 18 months, the transistor count in an IC chip is doubled. Now we are uh, having nanometer range ICs. So it contains billions of transistors. So for designing this kind of IC directly without any EDA tools, EDA tools is an electronic design automation tool, which gives idea of what our circuit will work when we are going to design this a particular hardware or architecture. Doubts in between, you can directly unmute your mic and ask. So as the transistor count is increasing, we can't directly go forward to produce the IC without doing a test. So for testing, we are using multiple EDA tools. When a client is giving us, I need a 3 nanometer microchip that I have to do some digital signal processing. Okay, so when he giving that instruction, we have to first that uh, that thing need to be picturized. For that, we are using architectural design. While the architecture is working properly or not, we have to check. For that, we are using Verilog. Verilog comes in the picture when we need to design an hardware and need to check whether the that particular architecture is working properly or not. So Verilog, VHDL, system Verilog are different type of hardware description language which are available. Verilog is more similar to programming language C. So it is a textual format of describing electronic circuits and systems. So different level of abstraction. Level of abstractions are what a internal module is describing is defined at 4 level of abstraction. According to the design, what we are going to design, it depends which level of abstraction we need to choose. The external environmental will not be affected, means it will not affect the system, but inside we are representing the same device in different modules. It means modeling. So we have different type of modeling. We have switch level modeling, gate level modeling, data flow modeling, behavioral modeling, in which behavioral modeling is the highest level of modeling. If we don't know the internal structure of an of a circuit, all we know the algorithm, how for a particular input, this is the output. That kind of information is only have. So for that kind of abstraction, we will go for behavioral level modeling. It's similar to C programming, as I said. Data flow modeling is the next level. At this, we will specify the data flow, how inside that module data is flowing. While programming, we will get to know that how this each level of abstraction is different. Then gate level modeling, we will be using different type of primitive gates such as AND gate, OR gate, NAND gate, and we are designing the circuit. That kind of modeling is called gate level modeling. And the lowest level of model is switch level modeling, in which we are going to use PMOS, NMOS, then switches, storage nodes, etc. But the thing is, switch level modeling is not synthesizable. It is the lowest level. So we are not going to discuss switch level. I just give an example at the end of this workshop, how we are going to design that inverter or AND gate or NOR gate using switch level. That is not really important level of modeling, but we need to know what is switch level modeling. Am I audible? So first we are going to discuss gate level modeling. So for gate level, we are using predefined primitive gates, such as I have written the AND gate, NAND gate, OR gate, XOR, XNOR, NOR, NOT, buffer. Okay. So getting into Verilog code, first we are going to design the module. Okay. Then we will discuss the test bench. I will discuss what is test bench later. First we are going to design the circuit. I hope everyone have studied digital electronics, and I am going to discuss hard after. So we need XOR gate and AND gate for that. So for starting a module, we use the keyword module. As here you can see here, I used module, and the module name I am giving as HA. Inside the bracket, we have to define the port. Different type of ports I am using is A, B, S, and C. Semicolon is used to terminate that line. Okay, as similar to C++ and C. So here I am taking input as A and B and output as S and C. So how to use predefined primitive gates? For calling that gate, we will use that keyword. We need XOR gate and AND gate. So I am using XOR, and we have to give some name to that gate. If we are using in this, if we are using two different XOR gate, the system need to understand what input gets this XOR gate and what input get that XOR next XOR gate. So we need to give a particular name for that particular gate. For that I am giving G1, and inside the bracket we have to follow a particular sequence. First we have to define the output, then we have to define the inputs. So for XOR gate, I'm using sum. So I'm using S as output, comma, A, comma, B. To terminate the sentence, I'm using semicolon. So the syntax is gate name, in bracket, we have to use output, then inputs. Okay. Then for carry, we have A and B. So AND gate, I'm giving name as G2. Then bracket, output is C, inputs are A, comma, B. End the module, we are going to use the keyword end module. You have to note that for end module there is no semicolon. Okay, so in real circuits, logic gates have some delays. So how to deal with gate delays in Verilog? So first we are going to discuss delay of delay time. So if you want to represent 5 nanosecond delay. So in this example, I have defined as 5 nanosecond delay time, and hashtag is used for that. Hash in bracket, how much delay time you want. Then you have to give the gate name and then outputs and inputs. If you want to represent rise time and fall time. So for ideal case, gate is having uh, signals that is pure square signals. So that is not the case in real time. There will be a transition delay 0 to 1 and from 1 to 0. That is rise time and fall time. So if you are searching ediplayground.com, you will be getting this kind of playground. Uh, First, you have to log in there. You can log in using Gmail or you can create an account. So this side is used to write the design code, and this side is used to write the test bench code. And what is a test bench? First, we are designing the circuit. Then we need to know whether the signals, whatever signals we are defined inside the module, is working according to our design. So the output must be verified before we are proceeding further. For that, we are using test bench. So how to write test bench, we will discuss with the same code. Okay. So I'm going to write module of header. Then we have A, B, then sum and carry. So that we have inputs A comma B, then output S comma C. So then we are going to initialize. We need XOR gate. We are naming it as G1. Then S is our output, A is our input, B is our input. Then we need AND gate, G2, then carry A, B. So whenever you guys are designing something, don't name it as A, B, S, and C. So for the understanding purpose, I have used the signal names as A, B, S, and C. When you are guys are designing, give some meaningful name to signal. Otherwise, if you are designing a large circuit or little bit complex circuit, it will be a difficult task for you to understand what I have designed. Okay, so this is our module. This is the design of our fader. Then going to test bench, we need module TB. In that, we need wire and reg. Wire is something that is just an interconnect, and register is short form as reg. That is need to used as a to store the values. So in test bench, whatever inputs we are used in the design, that will be registered. Okay, so A and B are registered, and whatever outputs, that will be wire. If you guys have any doubts, you can ask. Okay, then the next thing we have to do is instantiation. The HA module need to be called here. Whatever we have done for the primitive gates, same. HA, then we need to give a name to that module. For I'm giving H1. Okay. Then in the same order, whatever inputs we are given, in the same order we can give this here. Okay, like A, B, S, C. This is positional assignment. Another way we can do this is dot S of S. This is this not require that correct position. We can call like in our way, which means that we are assigning our signal S to the module signal S, then our signal C to module signal C, then our signal B to B, then A to A. So in this way you can do, otherwise you can directly go for the same position as mentioned here. As also we can name these signals different. That is also a case. If you want to name this as X comma Y, we can do that also. XY, and I'm using LM. Okay, so in that case, X and Y are our inputs. X, Y. And our outputs are L and M. Okay, this is also right. Understood, guys? Otherwise, h2 dot x of s x of a dot y of b dot l of s dot m of c. This is the other way. Actually, this is the basic test bench code what I am discussing. Then we need we need to give input values. So here I have not mentioned any size of x and y. So default it will take value 0 and 1 and x and z. X is don't care and z is high impedance. Don't go into that deep. We'll just discuss 0 and 1 now. Okay. So there is a uh, two blocks in Verilog. We will say initial block can always block. We'll say the difference of this in the coming slides. And just I'm going to do is we'll define an initial begin block. Then begin and end is used as curly brackets in C++. Why we are using curly brackets in C++? If there is more than one sentence inside a what do we say inside a loop or something, we will use curly brackets. Likewise, in Verilog, we will use begin and end. So initial is our block. Inside, we have multiple statements. That's why we are using begin. I will starting my x value as 0, then y value as 0. For every statement need to be terminated, we are using semicolon. Okay. Then after that, we have to give some delay. I'm giving 10 nanosecond delay. Then I am changing the value of signals to 0 and 1. Then again delay 1, 0. Then again delay 1, 1. Okay. For closing that loop, we are using end. Then to access EP wave, which is mentioned in this EDA playground, if we need to access the EPA wave, we need to use another initial block. This is a constant one. You need to memorize this. Okay. Term.vcd term was that then I'm calling finish. Okay. So I will explain once again. So in the right side, we can see the design of a of header. In that we have inputs A, B, and output as SC. And we have the equation S is equal to XOR B. So we are using XOR gate. Then name of that gate, output, then inputs. Likewise for AND, name of the gate, then outputs, then inputs, then AND module. That is our half adder design code. Then coming to the test bench, we'll start with the module. Module name is TB. You can name it as any name you want. You can name that. Don't name keywords. Okay. Then whatever inputs we have to give, that we will term it as reg, that is register. Then whatever outputs we have, that is wire. Wire is just an interconnect. We can't store the values in wire. Okay. Then we are calling this design to our test bench using the same what we have done for XOR and AND. We are calling that module name, then module we are giving some instantiation name. Then our inputs and outputs as the same as the port list mentioned in the design. Then for inputting our inputs, we are using initial begin block, initial. Then if we have multiple statements, we have to use begin and end. Otherwise, we can directly write initial, then x equals 0, y equals 0. If that is only the sentence there, we can directly use initial x equals 0, y equals 0. Okay. Then for accessing EP wave in EDA playground, this is common for any code. This part is common for any code. Okay. After doing this, we have designed our module and we have written the test bench for our code. Then we are uh, selecting our tool. We are using ELDII. Okay. Then we need to open EP waveform after run. That need to be ticked. Then we will save this.
Yes, sir, I have a question.
Yes.
Yes, sir, I have a question. Regarding that dump file or dump verse, I didn't understand the specific code. Like, what is the what does it do?
The thing is dump file VCD formatted that in inverted comma we have written dump.vcd. So
Yes.
after executing that code, there will be a VCD file. In that, various variables will be there. In that variables, how that value is varying will be written. So we need to export that file into dump.vcd to open in EP waveform. It's just
Okay.
an what we say a standard procedure to open EP wave.
Okay, sir.
Is means this is not directly connected with our design. For EDA playground only, we need to use that sentence. No,
Okay, sir. If we like don't do the dumping thing, like then we can't access the waveform.
EP wave. Yeah.
Okay, sir.
The thing is, Verilog is case sensitive, so take care of that also. All the keywords are in small letters. Everyone know the basic programming, right? C, C++. Hello. I'm audible, right?
Yes, sir.
Yes. Don't worry about this finish and all. We will discuss that later. That are system task. Okay, so you'll choose tools and simulators ALDIC. Then we will tick this open EP wave after run. We will run the code. Uh, because of the net issue, I'm facing this. So one question for you guys: if you want to design only AND gate, what we have to do the change in this code?
So the XOR part will be removed.
Yeah, so we also don't need the S port. Just we have to write A, B, C, then input A, B and output C. Directly write a G to C, A, comma B. That is AND gate. Likewise, you can create all the gates: AND gate, OR gate, AND gate. Anyone doing parallelly?
Yes, sir.
Yes, sir, but I'm getting error.
What you are getting?
I'm also getting error. Receive 255.
Okay, so after opening EP wave, it will, after running the code, the EP wave will automatically open. So we will minimize this first, and we will just go through the code. We are giving first as 00, then 01, then 10 and 11. For the particular values, for 00 S should be 0 and C should be 0. For 01 S should be 1, C should be 0. For a 10, same 10. So 11, 01. So how to look the code means how to look this. The same signals have been repeated. So I am deleting that using this and giving that B. Okay.
Sir, എന്ത് ചെയ്തപ്പോഴായിരുന്നു ആ കോഡിന്റെ എറർ മാറിയത്?
മുകളിലൊരു സെമിക്കോളൻ വിട്ടുപോയി ഇവിടെ ഡെം ഫയൽ ഡെം ഡോട്ട് വി സി ഡി കഴിഞ്ഞൊരു സെമിക്കോളൻ.
Okay.
Okay. So for 00, C0, SE0, for 01, 01, 10, sum is 1, carry 0. For 11, sum is 0, carries 1. Okay. So as predicted, our design is working properly. That is what we have done so far. Why I have taken half an hour directly is designing AND gate OR gate is waste of time. So directly I have taken some circuit and designed. This is basic only. I will be discussing so many codes later in this workshop. Any doubts? We are going for another module, modeling. We have only discussed this gate level modeling. Now we will go to data flow modeling. Okay. So the next modeling is data flow. If we know the equation, likewise we have already discussed for half adder that sum is AX or B. We are going to use in some operators in data flow modeling. For XOR, it will be this operator, as you can see in the screen. For AND, we are going to use this. Likewise, for OR, we are going to use this. And if you want to negate something, we are going to use first this. And this is NAND gate. I will show here. This is NAND. Okay. This is not. This is OR. Why that? Full stop. So we can combine NOT and different gates to get the complementary one. If you want XNOR, we have to use this XNOR. Okay, that complete operator list is mentioned in the textbook. I will give that textbook name in chat, so you can refer that. So the same Verilog code for Affordable we are going to design in data flow model. The same as module name is HA, then the ports A, B, S, C, which A, B are input and S, C are output. Then we are going to use the keyword assign. For data flow modeling, we are going to use the keyword assign. Assign S is equal to AX or B. That operator we are going to use. Then assign C is equal to A and B. Okay. Any doubts? Just I am going to edit this part only. The test bench remain the same. Why the test bench remain the same? Because inside whatever module means modeling we are using, that will not affect the external environment. That's why the test bench remains the same. So we are expecting the same results. We run the code. Uh, okay, so we are getting the same result here. Okay, so we need to design full ladder now in both modeling. Only the design part I need to discuss now. So module full ladder. Tell me what are the inputs we are going to give. How many inputs are there for there in a full ladder?
3.
What are the inputs?
A, B, and C in.
Okay, then what are the outputs?
Sum and C out.
Some and C out. Okay, so we have input A, B, A, B, C, and output sum and C out. Assign sum is equal to A XOR B XOR C in. Then assign carry equal to bracket A and B or B and C in or A and C. I hope everyone know these equations. Otherwise, create the truth table and solve it by K-map. The basic of digital electronics. You have to be strong in that subject for designing circuits. Okay. So this is data flow modeling. Same we will design in gate level model. A, B, C in, some, and C out. Input A, B, and C in. Output we have some and C out. So the thing is, for XOR gate, we have only one output and two inputs. So we need to use two XOR gate. First we have to XOR AB, then we have to use the result and XOR the C in. For that we have to use some kind of interconnection there. For that we need a wire. Okay, wire I am using X1. So that X1 is my first output of A and B XOR gate. Then I am going to do that X1 with C in. I'm only doing that some part now. Carry out I will explain. If you guys have any doubts you can ask. Why we have used that wire X1 there. Understood? Oh, not the yeah, wire X1. So this is the full ladder circuit. Full no, this is full subtract. Ladder. Okay. So we need to XOR our inputs A, B, and C in. Okay, then tell me how many wire we are going to require for carry in full ladder using gate level modeling. Question is how many wire we require to
Sir,
create
4.
carry. Why you have said 4?
Sir, 3 for the AND and 1 for the OR of the total.
Now I need to explain. I will explain what is the difference between data flow and gate level. We can simply see here for full ladder we are using only 6 lines of code for data flow. We are directly using the operators and we can directly write in one single line for that large equation. But for gate level, we have to use the primitive gates and we have to define that wire and we have to interconnect that. That interconnection is a tedious task. It will take lot of time and even interconnection for a large circuit may be difficult. Even that connection may go wrong. That's why that level of modeling is important while we are designing a circuit. Which level we have to go is depending upon the design.
Sir, carried AND gate and OR gate use ചെയ്തിട്ടുള്ളതെന്ന് explain ചെയ്യൂ.
ആദ്യത്തെ ആൻഡ് നമ്മൾ ഒരു വയറിലേക്ക് കണക്ട് ചെയ്യുന്നത്. വയർ നമ്മൾ യൂസ് ചെയ്യുന്നത് നാല് വയറാണ്. Y1, Y2, Y0, Y1, Y2, Y3. ഓക്കെ, സോ Y0യിലേക്ക് നമ്മൾ കണക്ട് ചെയ്യുന്നത് ഈ ആദ്യത്തെ പാർട്ട് A ആൻഡ് B. ഇക്വേഷൻ മാത്രമാണ് ഈ പാർട്ട് ഞാൻ റെപ്രസെന്റ് ചെയ്യുന്നത്. A and B, B and C in, A and C in. That 3 part we have to do AND gate. ആ 3 പാർട്ടാണ് ഞാൻ ഈ AND gate യൂസ് ചെയ്ത് ചെയ്തേക്കുന്നത്. ആദ്യത്തെ Y0യിലേക്ക് നമ്മൾ എയും ബിയും ആൻഡ് ചെയ്ത റിസൾട്ട് കൊടുക്കും. Y1ലേക്ക് ബിയും സിയും ആൻഡ് ചെയ്ത റിസൾട്ട് കൊടുക്കും. എയും സിയും ആൻഡ് ചെയ്ത റിസൾട്ട് Y2ലേക്ക് കൊടുക്കും. അതിനുശേഷം നമുക്ക് ഇതിൽ ഓരോ ആൻഡ് ചെയ്ത റിസൾട്ടും നമ്മൾ ഓർ ചെയ്യണം. അതിനുവേണ്ടി നമുക്ക് 2 ഓർ വേണം. അത് ആദ്യത്തെ ഓർ റിസൾട്ട് നമ്മൾ Y3 എന്ന് പറയുന്ന വയറിലേക്കാണ് കൊടുക്കുന്നത്. അതിന്റെ ആരൊക്കെ തമ്മിൽ ഓർ ചെയ്യണം എന്നുള്ളത് Y0യും Y1ഉം ആണ്. then final cout എന്ന് പറയുന്നത് ആദ്യത്തെ ഓർ ചെയ്ത റിസൾട്ടും then ഇനി ചെയ്യാനുള്ള റിസൾട്ട് y2 അതാണ്. മനസ്സിലായോ?
clear, sir.
അപ്പൊ ഇത്രയും ഒരു ഒരുപാട് കണക്ഷൻസ് കണക്ട് ചെയ്യുന്ന സമയത്ത് നമുക്ക് തന്നെ കൺഫ്യൂഷൻ ആവും. അതുകൊണ്ടാണ് നമ്മൾ വലിയ സർക്യൂട്ട് ഇക്വേഷൻസ് അറിയാമെന്നുണ്ടെങ്കിൽ ഡയറക്റ്റ് ആയിട്ട് നമ്മൾ ഡാറ്റ ഫ്ലോ മോഡലിംഗ് പോകണം. Means I have taken a symbol of a full adder circuit. Even in that full adder circuit, we are using how many gates? 2 XOR gate, 3 AND gate, and 2 OR gate. So writing code for a simple full adder is a lengthier one. So what will be it happens for an 8-bit triple carry adder or 16-bit triple carry adder? That will be a tedious task. So in that case, all we are going for data flow modeling. That is easier one as compared to full adder. But if you don't know that equation, only we know these are the gates we have to use for this output, and we have to connect that output to this gate. In that kind of fashion, if the client is explaining, then we have to go for gate level only.
Sir, actually, എയും ബിയും കൂടെ ആൻഡ് ചെയ്തതും പിന്നെ എയും ബിയും എക്സോറിന്റെ ഔട്ട്പുട്ടും ക്യാരി ഇന്നും കൂടെ ഒരു ആൻഡ് ചെയ്തതും കൂടെ ഓർ ചെയ്യുന്നതല്ലേ ക്യാരി ഔട്ട്?
എങ്ങനെ വേണമെങ്കിലും ചെയ്യാം, അങ്ങനെ വേണമെങ്കിലും ചെയ്യാം. ഇതും ഒരു ഇക്വേഷൻ ആണ്, അതും ഒരു ഇക്വേഷൻ ആണ്. If you guys know that circuit or truth table or equation directly, you can design in data flow or gate level modeling. I think it's clear. The basic structure of Verilog code I have discussed. The syntax will be same. First we have to define the module using module keyword, then we have to give the module name. Then inside that we are going to give the ports. Then we have to define whichever the ports are input and whichever ports are output. Then we have to define the definition of the module. That will be different in different modeling. Then to end the module, we are going to use keyword end module. I will share this PPT, and I have written some questions here. You guys go through after reading that textbook. Okay, you need to read the data flow modeling chapter there. In that, some operators I have mentioned there. Then what is the difference between that particular operators I have given with an example. I'm not going to discuss this here. And this is a unary, means conditional operator. You know what is mux? So mux is an important electronic circuit. You have to know that not only for the just function of mux, you need to go for the application level, and where we are using that mux in daily life, that need to be explored. Okay, so here I'm going to use mux 2x1. Inside I have written not only ports, I have written directly input and output. That is another way you can represent input port and output port. Here I have written input wire also. Even I have written output wire. You guys are seeing, right? If we are not representing wire, in default Verilog, it will take it as a wire. Okay, that is the first thing I have to explain. Then inside the port, when we are listing A, B, select line and wire, Y, instead we can directly write input as A, B, select line and output as Y. Okay, otherwise you can write like this. A, B, select Y. Then input A, B, then select. Then output Y. This is also correct. So it's up to you how to write the port. You can write inside this or you can write outside. Okay. Now I will explain this statement. Here we are directly using conditional operator. What is conditional operator? If select line is high, then we will choose B. Otherwise, we will choose A. That is the syntax here. Select line question mark. It asking whether select line is high or not. If it is high, then it will take the true value. Otherwise, it will take the false value. Okay. So tell me the other way to represent this mux. A select line y. Input A comma B comma select output. Tell me what is the equation of mux2 cross 1. If it is not select, then it will be A, or if it is select, then it is B. This is the equation. Have I got this equation? After solving the truth table, all the combinations we are writing in that, and the particular output we are representing. Okay. So K-map. I think everybody know how to write the K-map and how to solve this. Otherwise, learn that and solve 4 marks 2 cross 1 and verify whether I have written the same or not. If you are directly using assign statement, we can directly say that is fact of flow. Now we have to use gate level. How we are going to use gate level here? We need negated output of select, right? So we need another wire x3 and we will use not gate. Not in bracket we have to write x3 comma select. Then in the first line and x1 comma a comma x3 we have to use. So we need 3 wire x1, x2, x3. And we will use not gate and we are negating the select line and we are storing in next one. Then we need to use AND gate. First we are using next to A and x1. Then again and D3. Here we are going to take x3, then B, select, then OR gate before we have output y, comma, x2, comma, x3. Okay, this is the code in gate level modeling. Okay, tell me what are the registers we need? A, B, select line. What are the wire we need? We need Y. Then we have to call that module. I'm calling mux. Then mux name, whatever name you can give. Even you can give my name. And I'm giving K. Okay. A, B, then select. And we have Y. Okay. A equal to B, B equal to 0, select line equal to 0. 0, 0, 0 is 2. That's 0, 0, 0, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1. 1, 1, 0. This will be the test bench. Okay. We will declare TB, then register A, B and select line, fire Y, then mux, key A, comma, B, comma, select line, comma, Y. Initial. Give the conditions. Okay, A equal to 0, A equal to 0, select line equal to 0. I'm not going to type all combinations. I'm just giving an example. A equal to 1, B equal to 1, select line equal to 1. And then for accessing EP wave, initial begin, dump file, dump.bcd, dump pass, dot finish, and modify. And one more question I need to ask. If I'm giving as 10, how the computer gets to, means how the simulator gets to know that it is 10 nanoseconds. I'm saying the unit nanosecond. How the tool get to know that it is in nanosecond. Okay, in this side we can see that compile option. In that we are written time scale is 1 nanosecond per 1 nanosecond. That's why the unit is written, means it taken as nanoseconds. By 1 nanosecond by 1 nanosecond. This 1 nanosecond is precision. So if we are to include 10.5 or 10.23 nanoseconds, we need to adjust this precision accordingly. Okay, the first one is unit, so it is in nanosecond. That's why this 10 is taken as nanosecond, or this 100 is taken as nanoseconds. For that we are using time scale. Hashtag 100 is delay, represented whatever we are going to represent in hash, that is delay. In this EP wave, that time line is there. So for after every 10 nanoseconds we are changing our value of A and B. That's why we are written hash 10 there in that initial begin here. If we are not changing, means if we are not giving the delay value, it will continuously show this value only. It won't show. We can do that as exercise. Delete the delay in every combination and run again and check EP wave is showing all the combinations or not. After done was that hashtag 100 is delay. After 100 nanosecond, we are calling this function system task $sign finish, which is used to finish the simulation. So after 100 nanosecond, we will call the finish so that it will stop the simulation. Otherwise, it will continuously execute up to infinite time. Okay, any other doubts? You need to ask questions, otherwise you won't learn. Even small things that you are thinking like, that will be useful. We need to know that. Dollar monitor, yes, we can use dollar monitor. That dollar monitor, if we are using, we can get that in log here, whatever displaying here. That I will show in next example. Okay, how to use that dollar monitor. Behavioral modeling. This modeling is more important than other modeling because this is algorithm, which means that if we know the algorithm, we can do the modeling using this behavior. Only requirement is if the signal is high, then this output is high. That kind of, if we know that kind of thing, we can do in behavioral modeling. Most of the design we are doing in our industry is using this behavioral modeling only. Most of the designs, because all of these examples I have given is combinational circuit, right? That is combination and sequential circuit.
So sequential is a particular circuit where the current state depends upon the past state, and combinational you get a set of inputs which produce a particular output, like the half adder.
So you are saying that for sequential circuit we need a memory.
Yes, like it depends on the previous state for an output. Combinational, you get a set of inputs to get an output.
Yeah, okay, that's correct. So for that designing means for every sequential because in all other modeling we are saying that even we can design the simple latch circuits using data flow and gate level modeling. That's not an issue. But when it comes to level sensitive circuits, such as SR flip-flops, so that is sensitive to edge of positive edge of clock or negative edge of clock. That edge sensitive circuit designing, we will be requiring behavioral modeling. So both combinational as well as sequential can be designed using behavioral modeling. Behavioral modeling is the highest level of abstraction. Then behavioral modeling have uh, two statements, procedural and structural. We will discuss this always an initial in this part. Then after that, procedural assignments we will be discussing in next. We will be discussing all the flip-flops, timing controls to data flow and gate level. So first we are going to discuss what is always an initial. Basic statements. Okay, for behavioral modeling, these are the basic statements. Every every behavioral statements can only appear inside this structured procedure. That is always or initial. If we are writing in an design, if we are writing in here, we are writing initial begin and writing s is equal to a and b. Instantly we can say this is behavioral modeling. Or in case if we are using always begin s equal to negation of s. I am simply writing some example, okay, for understanding. So these are the two structure we will be using in behavioral modeling. So when we are using initial block means it will start execute at simulation time equal to 0. We are representing any statement inside that initial block, it will start executing at time equal to 0. But always is not that case. Always requires some what we say condition. If that condition is satisfied, then that always block will execute. Otherwise, that always block will not execute. Block one more time or always. That nesting is not allowed inside these statements. Okay. Any doubts? If in the case of always block, there is a condition. Whenever the condition is means looping kind of purposes. So here is an example how to use that initial statement. I'm using a register. The next thing that we will be using in design statements, for every output in design, we are going to use registers in behavioral modeling. In all the other modeling, we just represent it as output y, means output y, output s, comma c. Now, in behavioral modeling, we are going to represent it as output reg y, output reg s, comma c, because it need to be stored that particular value, because it depends upon the previous input also. So it need to be stored. So we are going to use registers in behavioral modeling. Okay, even if it is combinational or sequential, it need to be registered. Otherwise, we can't use this initial and always block inside a design module. Here, okay, in data flow and gate level, we are using output s comma c, right? We are not representing it as wire or register. So here, this line, both this S and C will take it as wire only. But in behavioral modeling, if we need to use these structure procedures, that is always block or initial block, we need to represent the output as registers, because it need to be stored, means that whatever value is coming to that variable need to be stored. That's why we are using register. Register is a, in a circuit, register will be acting as memory. It will be a single bit in, means single bit memory. Every register will act as memory only. Okay. So here I am taking count as register, which contain 4 bit. How I get to know that it is 4 bit? Because of this array 3 is to 0. Then I am using that statement initial begin. Whenever it start at time equal to 0, simulation time equal to 0, the count value is 0. Okay. Then I am using the condition while if count is less than 10, then display. This is another system task that can be used uh, to display the count value. So how I am displaying that count is to percentage 0D or directly you can write D. Then comma our variable count. The this count variable contains some values. That value will be given to this D, percentage D. So in output, we can see that count is to value. Display is a system task. It is used to verify in log file itself higher level as compared to data flow and gate level. You need to for better understanding. Any doubt? Okay, moving on. The next one is always statement. Only when condition is satisfied or in a looping fashion. If we are not giving. Okay, so always block. As I said, it will start at time equal to 0 but executes in a loop fashion. Means if that condition is satisfying, it will execute continuously. For basically every always block, whenever there is requirement in a clock generator, we will be using always block. Always after 10 nanoseconds or 5 nanoseconds, we need to negate the value. Okay, then it will toggle by 1 0 1 0 1 0 1 0. It will be creating a square wave. For generating that, we will be using always. How to create that clock generator? I have explained this code. Module clock gen, then I have only output clock. I have taking that output as register clock. Initial First initial value of clock was 1 tick B0. What that represents is it is 1 bit of binary. Okay, if I am writing 1 bit decimal 0, that is decimal, then 1 bit hexa of 0, that is hexadecimal, then 1 bit of no, x, that is hexadecimal, then O, that is octal. Okay, you don't need to worry about this now. We will be dealing all the values in binary only. Okay, so it is 1 bit. How I get to know that is 1 bit? I'm not representing any array here. If I'm representing any array like this, here count is 4 bit. Here I am not representing anything, so it will be 1 bit. Okay, so 1 bit 0 is the initial value. Then I am writing a always clock. For every 10 nanoseconds, the value of clock need to be toggled. So the total time period will be 20. Whatever value we are writing here, that will be half of the time period. Okay, then I am using initial block. I am not what is a nesting. Initial block and always block. Okay, here initial block contain only one statement. That's why I'm not using begin and end. After that only I am using always. I'm not using this always block inside this initial. Okay, we will be stopping here and we'll be continuing next